Sir, we can start by.
Today, sir will be speaking on
Thank you, sir.
research carried out by Nobel laureates in physics in 2023. As we know, two Nobel laureates will be awarded. One, Dr. John J. Hopfield from Princeton University, USA. The other scientist is Jeffrey Hinton from University of Toronto, Canada. According to Nobel Committee, they've been selected for the Nobel Prize for foundational discoveries and inventions that enable machine learning with artificial neural networks. These two Nobel laureates in physics have used tools for physics to develop methods that are the foundation of today's powerful machine learning. John Hopfield created an associative memory that can store and reconstruct images and other types of patterns in data, while Dr. Jeffrey Hinton invented a method that can autonomously find properties in data and so perform tasks such as identifying specific elements in pictures. So, sir will be speaking on the works of these two Nobel laureates. Before beginning the talk, let me have the privilege of introducing Dr. S.N. Omkar, sir. I'm sure all of you know him very well. Sir is a chief research scientist at the Department of Aerospace Engineering at the very prestigious Indian Institute of Science. He is the honorary professor in yoga at Vedic Wellness University. He is also yoga consultant at Shankara Cancer Research Foundation. He is the chairperson of standardization of drones committee by the Bureau of Indian Standards, and he is also the convener for standardization of agricultural drones, a special committee by Bureau of Indian Standards. He is also the chair of Center for Advanced Air Mobility. Dr. S.N. Omkar sir's research interests include satellite image processing, uninhabited aerial vehicles, drone computing, nature-inspired algorithms, biomechanics, and yoga. He is also pursuing several projects and research work in the area of satellite and UAV image processing, and he has also worked on flood and disaster management. And he is also a great expert in yoga. Sir has developed several algorithms and used them for a variety of applications like road extraction, flood assessment, crop classification, crop growth and analysis, radiation monitoring, etc. The other facet of Dr. Omkar sir's research includes composite design optimization using nature-inspired techniques. He has also pioneered in using biomechanical simulation framework for analysis of yogic postures. He has established a lab facility for this. Dr. Omkar sir is also a celebrated practitioner and teacher of yoga, which all of you would be knowing. He has been conferred with many awards, including the very prestigious Karnataka State Rajyotsava Award from the Government of Karnataka and the Kempegowda Award from Bruhat Bengaluru Mahanagarapalike for his contributions in the field of yoga. Sir has published many papers and reports. He has been invited for talks throughout the country. He has delivered more than 110 talks in India and abroad. He has also delivered talks in All India Radio. More than 92 talks he has delivered, and also on many TV channels. You have, I'm sure, would have seen Dr. Omkar sir, especially in Udaya TV, ETV, Z Kannada, DD Chandana, etc. And he has also written many articles for news dailies and magazines. With this very brief introduction, may I request Dr. Omkar sir to take over and deliver his talk. Over to you, sir. And once again, welcome to you. Thank you.
Namaste, Namaste, Dr. Ramesh and other participants. Thank you for joining. I also thank the Karnataka Science and Technology Academy for giving me an opportunity to share a few of my thoughts. But before I begin the talk, I should submit that this is not going to be a purely technical talk because I am too small to comment on the great works of either John Hopfield or Jeffrey Hinton. But the idea is I take this opportunity to just mention broadly what they have done and trying to look at some of the highlights more than the technical details. Just what perhaps a general population would be interested to know about their contribution and some of the highlights from their work, and also to let you know about some of the work that we have been doing in the field of AI, parallelly, because ಕನ್ನಡದಲ್ಲಿ ಒಂದು ಮಾತಿದೆ, ಹೂವಿನ ಜೊತೆ ನಾರು ಅಂತ. ಹಾಗೆ in the light of their work, I also try to push some of the small work that we have been doing at Department of Aerospace Engineering, Indian Institute of Science. So that is my humble submission, is that I'm too small to comment on the deep work that they have done as physicists. But nonetheless, we have been using the ML and DL. In fact, I had heard about Hopfield because I used to teach this neural network course in IISc. So I have taught about Hopfield network. At that time, honestly, I did not know that he is a physicist, etc. Of course, I have heard of Jeffrey Hinton very vaguely because we know that he is one of the main motivators for many of the work that we do today. With this, I will go on to my presentation. Share the screen. Give me a couple of minutes. Yeah. Is it visible?
Yes, sir. Visible, sir.
Okay. So this time Nobel Prize in Physics, what you see here in the figure is, of course, top left is Hopfield, and then right is Feynman, who is also a Nobel laureate and a great physicist the world has known, and we all are familiar with his lecture series. And bottom down is the other Nobel physicist with Hopfield. He has also shared the Nobel Prize in Physics. He is also known as the father of AI today. And of course, the bottom left, everybody will recognize. I don't even have to name him. He is so famous. He has become an icon of physics, none other than Einstein. Well, Einstein is an embodiment of natural intelligence. People talk a lot about his IQ. In fact, because we are from Karnataka, natural intelligence means we also remember Sir M. Vishweshraya. So people always wanted to study the brain of Einstein and the brain of Sir M. Vishweshwaraya, very amazing. But now we are talking of brain outside in the computers. That's how from natural intelligence we have transcended so much to artificial intelligence that is amazing, to the wonderment. Instead of machines learning from human, now we have come to a stage where humans are learning from artificial intelligence as though brain is sitting outside. In fact, many of the information that I am going to present now actually comes from all these AI tools. They have matured to such an extent that you can extract a lot of information from that. So now we are wondering whether we are training the AI or AI is training us. That's where we have come to that kind of a crossroads we are trying to hit at. What do you go next? Okay. Well, where AI has reached, you see the very recent newspaper title here, heading, How AI responded to Chief Justice D.Y. Chandrachud's question on death penalty. You know, our Chief Justice has quoted this in one of the um, occasions where he has asked a question about death penalty to the a large LLM model, large language model, said this death penalty should be given. And yes, incidentally, it has given an answer positively affirming that it has to be there. Why we are talking about this is that even people of the caliber of Chief Justice, it has got the attention of them also. And we also know today that in various countries, especially in the US, the LLMs are becoming very popular because they can store a number of informations, all the current courts of justice, and with all case histories of several years can be stored, and it can pick up, quote, collect the information, give you the gist of everything. That is the level it has reached. You can put hundreds of pages of documents you can upload. If you look at the ChatGPT 4 and ask it to condense it for maybe 2 pages or 3 pages, which you can comprehend very easily. So all the way the advocates or the law people look at these documents, now it has changed. And India and US, there are initiatives strengthening the defense ties through AI and supply chain initiatives. There is a strong move on this. Chandrayaan 3, Mars and Gaganyaan missions. The Union Minister Jitendra Singh has stated that artificial intelligence solutions are a part of these various ongoing projects in the ISRO. Then farmers in India are using AI for agriculture. Incidentally, we have also used, I don't know whether we have included that in our presentation, but if it is here, we can look at it maybe later if there is time. I'll show you what we have done in our lab to predict the tomato yield, mango yield using artificial intelligence. So this is just to show the extent of the application of AI in real world. Most of the areas, I think today AI is an integral part, be it in industry, academics. It is spreading its wings a lot. So origins of deep learning, if you look at, it all started with 1943, McClopitt's neuron, where the first artificial neuron model was proposed. It was a very, very simple model with few connections. Then this was further developed based on the Hebbian learning uh, into a perceptron model. And in fact, a book also by the same name, Perceptron, was published. Lot of hopes came, but very soon this field lost the flavor because a perceptron, they thought, that cannot mimic anything non-linear in nature. It is then, I think, the works of Hopfield and Rumelhart, others came into field. Hopfield network really came, where he showed how these several neurons can be connected and how bringing closely connected neurons or artificial neurons can help to store certain information. 1986, I think the Hilton's breakthrough in training deep architectures, and especially the algorithm called back propagation algorithm. This is the one that revolutionized the whole aspect, where they could use the so-called brain-inspired architectures to solve several engineering problems. So from 1958 to almost 1986, there was a big lull in this area of neural networks. They thought that this is the mimicking the brain or brain-inspired architectures may not take us anywhere. But after 1986, there is a huge, we should say, an explosion in this area. And by 1990, we already had a dedicated journal in neural networks. So that is the impact of the work of Hopfield and Hilton. And incidentally, although these things, the neural networks had a lot of engineering applications, it has solved a lot of engineering, then it has percolated to medicine. What the point to be noted is that both Hopfield and Hinton, they are not engineers basically. They come from some other background, as we will see. So this is the genesis of how this deep learning today, what we talk, this deep learning, ML, DL, these two words have almost come to the normal public jargon. So to say, AI is normally quoted and almost it's, so to say, it has become a layman's term. So this is the statement from the Royal Swedish Academy of Sciences on honoring these two people with Nobel Prize. This year's two Nobel laureates in physics have used tools from physics to develop methods that are foundation of today's powerful machine learning. This is one of the biggest thing, a great thing, because these ML and DL has transcended the boundaries of the Earth. It has gone even to the space in terms of Chandrayaan in our own country and several other countries in their space missions. These MLDL has found a place. But the roots for this development has come from some very, very fundamental understanding as to how the atoms work, which are rooted in the subject of physics. So that is what is of great interest. And these two persons, the stars of today, the physics Nobel laureates, John Hopfield is from Princeton University, is a Howard A. professor in life sciences, Emeritus and Professor of Molecular Biology. This is something amazing combination. Today we are talking of interdisciplinary research, and we can see in Hopfield how that interdisciplinary architecture is very much embedded in him in actually getting to this level of receiving a Nobel Prize. Similarly, Jeffrey Hinton, University of Toronto, Canada, Emeritus of Computer Science at the University of Toronto. Although today, the moment we say computer science, we always only remember engineering colleges, because highest intake today in any of the technical university is computer science. So much so that many of the hardcore engineering, they are almost taking a back seat, especially if you look at the civil engineering, mechanical engineering. There is almost it is dwindling, whereas the computer science is swelling, and especially with ML and DL in forefront. And it is nice to know that the main reason is the works of some of the greatest scientists. More about Hopfield from Princeton University. He was unaware that he is nominated and he is awarded. This has become possible because of the blending with physics, biology, and neuroscience work that he had done. He has worked in all these fields. What fascinated him long back is how the atoms work, and the model that he had proposed long back with the assumption of simple electronic circuits resulted in modeling of an artificial connected neurons. So when this word of award reached Hopfield at a small cottage where he is staying right in now in England, he went on to say that my wife and I went out to get a flu shot and stopped to get a coffee on the way back home. And when they returned home, to find a flood of congratulatory emails that Hopfield himself described as astounding and heartwarming. So this was a big surprise for Hopfield. Well, this is just to highlight the interdisciplinary nature. Our own Venkatraman Ramakrishnan from same again Princeton University. This is just to highlight, because he was awarded the Nobel Prize in chemistry, but initially he got trained in physics, then shifted to molecular biology, and then 2009 for his pioneering interdisciplinary research on ribosome structure, bridging physics, chemistry, and biology, he was awarded the Nobel Prize. And I had the fortune of seeing him also, because he is a regular visitor to this great campus of Indian Institute of Science. So in a similar way, Hopfield, for his interdisciplinary approach, so this is why the interdisciplinary domain knowledge is of great use in producing some out-of-box approaches to life. So in essence, the Hopfield networks are inspired by the brain, in the sense in the brain, as we all know, it is a highly interconnected system. In fact, humans have close to 100 billion neurons, each of us, and each is connected. And the number of connections, they say, it runs to trillions, and they can run to somewhere close to the number of elementary particles in the universe. So it is such a complex system. And through this interconnectedness, Hopfield was the one first you showed that what you see in the figure is just a representation of the two magnets. When you heat one of them, how their connectivities change to drive the system to minimum energy. So Hopfield's contribution stems from this basic understanding of physics, and through this how one can store, because how our brains also work is because of this so-called associative memory. We have a highly interconnected system in the brain. That's how a lot of association are possible. That is how even when one of the neuron dies, we don't actually lose the whole memory because it is not stored in one location. It is stored as a system of interconnected neurons. So a lot of work has been done on this. Given an image, of course, then used to be zeros and ones. That's how you see a binary image. This is how initially things started. And you can store a binary image in a Hopfield network. And later, even when you give a partial image, as you show in the third figure, the weights, they get adjusted and you can recall the image either as a image top or bottom depending upon the values zeros and ones. So this is something amazing, how an artificial system can recall an image. Because for us the humans, it happens so automatically. Even an illiterate, even a child, it happens just like that. Whomsoever we see, we store their image automatically and we can recall in most of the times. And to make it happen artificially, that is a breakthrough. And that breakthrough is what Hopfield's contribution to the area of MLDL. Today it has become so obvious because the algorithms have matured a lot and they have reached a state of plug and play. That is how many may not recognize the breakthrough provided by the Hopfield and Hinton. But this is the kind of work they did. And now you see, because Hopfield, what he did is it took a simple network, which we call as the Hopfield network, where a system of nodes are connected and through some formulas. I will just show you some simple formulas for the sake of completeness, but what they have done is how minimizing the energy, they can store image and recall image. Then Jeffrey Hinton, University of Toronto, he is recognized as the godfather of AI because he used this Hopfield's model to generalize the connections into what we call as the Boltzmann's machine. And his reaction to Nobel Prize is the following. When he got, I am in a cheap hotel in California without an internet connection and with a not very good phone connection. I was planning to get an MRI scan today, but I guess I will have to cancel that. I have no idea I had even been nominated for the Nobel Prize in Physics. I was extremely surprised. This is the statement he has made. I mean, one side, well, both for Hopfield from his statement where he was living. And from the statement of Jeffrey Hinton, what we make out is their simplicity. And today, ML and DL means the people who are applying it, the companies which have made use of it, they have all grown really big and really rich. But look at the simplicity, number one. Number two, both of them never had any clue that they are even nominated for Nobel Prize. So it is a great recognition. And you can see why I put AlexNet. This is one of the initial networks that came, which showed to the world that this kind of a thing is possible. Then deep belief networks and back propagation algorithm. This is an amazing algorithm. Till this algorithm came, nobody believed that neural networks can have a tremendous impact on solving some of the real life problems, and that interconnectedness of the networks. Today, the ML and DL, the success has come from their interconnectedness, huge connected networks, what they can do, how they can extract the features in any complex data system, how a huge data set can be used to extract the knowledge in them. That kind of a knowledge mining, so to say, is possible. And that is because of the fundamental work that both Hopfield and Hinton have done. Another interesting fact about Jeffrey Hinton is his lineage. He has a very great lineage. His great grandfather is this person, George Boole. The catchword is this Boole, because I'm sure most of us have heard of this Boolean logic. This is this person, the mathematician whose work laid the foundation for modern computer science, the Boolean algebra, Boolean logic that we have all used initially while solving some problems with the gates. At 16, he began teaching to support his family. He established his own school at the age of 19 and later ran a boarding school in Lincoln. So, this is the great grandfather of Hinton. So, this shows that somewhere this kind of a mathematics needed for revolutionizing the computer science were very much running in the very DNA of this honored Nobel laureate Hinton. I thought I should share this information for all the listeners to show how not only we talk of the network has to evolve, but this kind of evolutionary thing started with his great grandfather, and today we see them maturing into a Nobel Prize. Well, this is the essence of contribution of Hopfield. On the left side, you see a simple network connected, and you see they are all interconnected. The connections are represented by the weights, and the other nodes, initially they had only zeros and ones, but today we use a lot of nonlinear transfer functions. We will not go into those details, but Hinton used the Hopfield simple network as the foundation, and but what he did was he again multiple layers of it he used to create what is called the Boltzmann machine. which could really do, because of the hidden nodes, lot of wonderful things by using some of the probability theory, etc. So we can see that these are all rooted in hardcore physics with the atomic physics, and then they modeled it to do some great work. So Boltzmann machine often constructed in two layers. You can see top and bottom layer, and with connected, and well, I will not go into the uh, basics. Just to tell you, they construct an energy function. W is the weight, that is the connection between those things. That weight is actually the learnable parameter. That's what it is. Because based on this, there are several offshoots we can see that has come, and through this system, including the restricted Boltzmann's machines, which came later, restricted in the sense not all connections are considered. Some of the connections you can see in the top layer getting removed, only the bottom hidden connections are maintained, so that this could do a lot of work. It could um, do movie recommendations, and there are a lot of quantum versions the IBM has proposed and used for machine learning. So this could do a lot of real world storage. Today's convolutional neural networks, so-called CNN, etc., have a lot to borrow from this connected architecture. So that is how the Nobel Academy decided to honor these two people. So physics helped in creating a lot of ANNs or artificial neural networks. Now you see the other impact. The ANNs are actually also helping in pure physics. This is what we need to recognize. The artificial neural networks are being employed as a function approximator and are used to provide the copycat for the physics model in question. In the sense, from the sound basis of physics and mathematics, they were able to construct artificial neurons, neural networks. Now, these neural networks are being used to construct mathematical models. We mean that in any experiment, you can have an input and an output you can measure. But in between, there is the plant. How do you model the plant? Many times it is impossible to actually construct the model because of the complexity, high dimensionality, and non-linearity. When all these things are there, it is not possible to actually construct a mathematical model. Only you have the data. Now from the data, can you construct the mathematical model? Yes, that is possible. That is where artificial neural networks are used. Now you can see the connection. From basics of physics and mathematics, they constructed a simple artificial neuron. That is the contribution of Hawkfield. How to connect them, that what Hinton showed. How to connect them to make it really highly connected architecture like our brain. Now later scientists have shown that how that can be used to model even the complex mathematical models for physics. So examples are artificial neural networks improved the sensitivity of searches for the Higgs boson at the CERN Large Electron Position Collider and were used in the analysis of data that led to its discovery at the Sun Large Hadron Collider. Incidentally, Higgs boson, he also was awarded the Nobel Prize for, discovering that boson particle, so-called the God's particle or the God particle. Ian has also gone into astrophysics. In astrophysics, they take a lot of imagery. Now, to make sense out of those imagery is not an easy thing. Couple of examples I've given here. CNN-driven analysis of data from the ice cube neutrino detector at the South Pole, which resulted in a neutrino image of the Milky Way. You can see in the figure. Exoplanet transits have been identified by the Kepler mission using artificial neural networks. So this is how we see the positive feedback, what physics gave to modeling the neural networks. Now neural networks is giving back to the physics to model some very complex phenomena in nature. The Event Horizon Telescope image of the black hole at the center of the Milky Way used artificial neural networks for data processing. So this is something amazing developments of how the works of Hopfield and Hinton have been doing. Now it is not whatever is happening with what started with fundamental understanding and modeling of Hopfield and Hinton is not, a road of roses. They also have thorns. And who is saying this? The very same people who laid the foundation for today's MLDL gala that we are all seeing. Jeffrey Hinton, in May 2023, he resigned from Google to openly discuss the risks of AI, emphasizing the need for free dialogue on the subject. He was with Google to work on MLDL to guide them. He had great collaboration with them, but Google did not wanted Hinton to say anything against MLDL. I'm not quoting anything in secrecy because these are all well documented phenomena. So he had to resign because he wanted to be very vocal about the dangers of AI. I will also present some studies based on our own experience how this AI could be little dangerous. Following his Nobel Prize, he called for urgent research into AI safety and establishment of guidelines to control AI systems that could surpass human intelligence. This is a very serious thing. In fact, today we had a meeting from Bureau of Indian Standards. I am chairing the standardization of drones in the country, where we were also discussing about drones and AI. This is an area in which we also work, and in the coming days, AI is going to be one of the key factors in drones. So I always recall the image of Lord Vishnu sitting on Garuda, his vehicle. Garuda is like the drone which can fly. Narayana or Vishnu, Narayana is nothing but an embodiment of the knowledge or intelligence. So intelligence today is AI. So AI is sitting on drone. So that is why I recall the imagery of Garuda and Narayana. But Narayana always had a one motto, to protect the dharma. Therefore, that knowledge is always good. But with all what we are seeing, what is happening in the world, with all the Russia, Ukraine, and today drones coming to the war field and AI sitting on them, well, these concerns are no longer to be taken lightly. Concerns of people like Hinton, well, establishing guidelines to control AI systems should be viewed very, very seriously. And there is a dedicated journal, AI and Ethics, to look at these things. Hopfield also has expressed his concerns. In March 2023, Hopfield signed an open letter advocating for a pause on AI systems more advanced than GPT-4. This is a large language model. Today, we are all using this, citing risks like human obsolescence and loss of societal control. Now itself, what is happening is we are all using ChatGPT. All our youngsters are using ChatGPT. Today, even teaching has become, we are all looking at how to teach any of the technical subjects. Giving assignments is actually losing its relevance. When you give an assignment today, any young fellow definitely can go to ChatGPT, give it, it will give everything in whatever format you want, not only this, in whatever handwriting style you want. Incidentally, I can train a network with my handwriting and get the things, not in any Times New Roman font, etc. I can get the material in my handwriting. It will mimic my handwriting. That's the kind of thing. This is what Upfield wrote much before he got the Nobel Prize. But after getting the Nobel Prize, at a Princeton press conference, he compared the discovery of AI to that of a nuclear fission, noting its potential for both beneficial and harmful consequences. Look at the statement made by none other than John Hopfield. As a physicist, I am very unnerved by something which has no control. So I think this is where there is a great concern. Although we wonder with amazement the kind of work, the possibilities that one can do with AI, but these are real concerns. With this, I'll just show you some of the applications, not all maybe, but some. One of the good work that we did long back is using AI, what we call as AI for good, for violent activity detection. We call it as eye in the sky. We have a drone lab where we can collect imagery from drone. The intention was that when you fly drones to monitor the mobs, suppose in Kumbh Mela you are flying some 50-60 drones, all of them sending video feeds. The whole idea is they want to identify the unrest or any spark of violence anywhere so that action can be initialized suitably in that area. But so many feeds coming onto a ground control station or a television screen, very difficult for human to monitor. So our idea was, if whenever any violence activity like hitting, kicking, etc. takes place, can the image processing identify? We have proved using ML and DL architectures, it is possible to pick up violence activities. What you see in the top left corner is our airfield and our own students, because data is very important. we created our own data set by doing mock drills of hitting, kicking, snatching, etc. Then we trained our own networks. We used a 64 connectivity network to identify the human, because in any scene first we have to identify the human, because if two dogs are fighting, we cannot flag it as violence. It has to be human. Then we have to do their pose estimation. Then we have to recognize their orientation. Then we have to classify it as whether it is violence or not. We were able to successfully do that, and we published it in one of the leading international conferences, CVPR. My student Amarjot Singh is the first author. You can Google and find out. The BBC interviewed us for this. Apart from that, we were quoted in various magazines. The BBC
devised a new
interviewed us.
system teaching drones to
I'll
spot
not bore you
violent
too much
behavior
with this.
in crowds using AI. Let's talk to two of the scientists who conducted that research. Dr.
Yeah.
Omkar
This
is from
just
the Indian
one
Institute
of,
of Science, and he joins us.
I'll just go to the essence of, because I don't know whether the sound is coming or not. But essentially what this work is that we used these MLDL models. We trained our own data set. But the whole point is that we were able to identify the violence activity. But the problem is we can identify more than that. That is why the ethical issues come into picture. Then we also worked on disguised face identification, again using artificial neural networks or the MLDL. Disguised face identification means you wear a mask and a goggle and a cap. Still we are able to pick up who you are. That's another work we did that is also presented in a leading CVPR conference, and this was also featured in BBC. That is what you are going to see next.
Devised a new system.
Still to come on Daily Planet, facial recognition software just got better. Like, it doesn't even need to see your
We
face.
have a 14-point architecture.
That story is up in a few
We
minutes.
trained our own lab interns.
Discoveries now. When it comes to facial recognition
There's
software,
also-
well, there's one thing you usually need, and that is a face.
First author is
well, that
Amarjot
was
Singh, my
until
student.
now. The disguised face identification system uses an artificially intelligent
Can
neural
wear
network.
artificial
Researchers found
mustache,
countless
beard.
images of faces that were
Even a lady
disguised
can wear
with
a
masks, hats,
mustache
scarves, and other
and
coverings.
beard.
So when it sees a covered face, it measures
You
the
can
distances
still
and
pick
angles
up
between 14 facial
who
points.
she
They
or
got
he
10 on the
is.
eyes, 3 on the lips, 1 on the nose, and then it estimates what the structure of the hidden face should be, then compares that with a database of learned faces to come up with an image.
The algorithm still needs more data, but in early tests, it was able to come up with a correct identity for faces hidden by hats or scarves 56% of the time, which means I can still safely wear my Mr. Robot mask and not be detected.
Yo, good luck. Not for long.
Well, when we published this, immediately response came from one of the professors in the MIT University that this is a dangerous algorithm. The reason is the intention with which we did is that when criminals want to disguise themselves with various masks, etc., we could identify. But the argument from the other side was that even celebrities mask themselves and move, disguise themselves and move around, and if we can pick up that, this can be dangerous. So this is what it is. That's why I wanted to share this with you. Not only that, but there are good sides of this. For example, you see, this is what we have developed for autism kids. You know, some of the gamified algorithms like this, couple of them you are seeing on the screen, and we want to help them. So this is the positive side of AI, so-called AI for good, to develop their motor skills for autistic children. We can do. We can also extend this for for the good of breast cancer, because it is one of the most hunted cancer, and post surgery For rehabilitation, if they don't do, they get into this condition called lymphedema, which can interfere with lifestyles. Therefore, to prevent that, some simple exercise systems we have designed and we have automated it using AI. That's what you can see here. And we have also done AI for agriculture. I forgot to include those slides here. If time permits, I'll try to pull out from some other PPTs. Let us see. So these are all the positive side of AI, but they do have their negative side. Giving them too much control may obsolete the human, and they can come to a stage where they themselves can take decision. Because on the lighter humor, again, this is from ChatGPT. So it so happened that a robo went for an interview. Of course, robo means it no longer looks like a robot, it looks exactly like a human. And when it went, the interviewer asked all questions, it was able to answer perfect. And then the interviewer asked, what do you want to be in the next 10 years? Because generally for youngsters, the CEOs or anybody would ask, what do you want to be in next 10 years? So it said, I want to take over the world. Then suddenly it said, it stopped, then no, I just said it, but I want to be something big. That's what it said. Then afterwards it came out of the interview and there were several other counterpart robots that were sitting. Then it said that, oh, by chance I told him the truth, but then suddenly I recollected, I told him that no, I just want to become something good. So they may have their own agenda. It can reach to that stage. Well, I just wanted to offer my tributes to, because I am from IISc, IISc's first Indian director, Sir C.V. Raman, happens to be the first Asian Nobel laureate for physics. And he said that the true scientist does not only look for results, but seeks the understanding of nature. And it is from such an understanding that Hilton and Hopfield provided this modeling of neurons to the world. And today you can see the impact of their work, how it has come. And we only hope that this impact would do only good to the whole world. Well, guess who is this? I'll tell you, I just wanted to know, is there anything, some facts about these two gentlemen, both Hinton and Hopfield? And I asked my students, incidentally, my students, Samay Patel, or Yajat Goswami and Tarun, they helped me with some information also in preparing the PPT. And in one of the GPT conversation, they picked up that Hopfield's hobby is violin. He's also a violinist. Then we were wondering, where is this? Then on query, we found out that it is not true. In fact, this gentleman is Hopfield. Then the ChatGPT itself revealed that, sorry for the information, this is not true. Then my student Tarun said ChatGPT 4 has another option. What is that? I can create an image for you. What it will do? You simply say, I want to see Hopfield with a violin. Then you can see the left side picture. Now you see, you can simply make a blunt statement, which is not true, that Hopfield is a violinist also. And you can generate an image to prove that your claim. And this is on the lighter side. Don't take it seriously. This is just to tell you that how lies can be faked using this so-called AI. So this is something very, very dangerous. This is why these two great people who have been honored the Nobel Prize, citing the current advancements of AI, they themselves are raising red flags about AI. I think that's why I thought I will include this fake thing, although I know that this is really not legal, but I just wanted to use this opportunity to show our distinguished listeners that these kind of things are the reason why they are raising red flags. AI hallucination. And that's what you see even in the chat box. Whatever I said, it's all captured here. That it's itself apologizes for the confusion, but you can still go back and create this kind of image to prove your false claim. So this is only tip of the iceberg, but giving autonomy to AI, well, that could be dangerous. And recently we saw one very, very sad thing. One of the youngsters in in US, he was chatting with one AI app and he got so enamored and he was so infatuated with that AI tool. He believed that this is really there. Then he learned that this is in some virtual environment and he, with the intention of getting into that virtual environment, committed suicide. You can just look out these kind of things. So this is something that we should be aware. We should know the limitations of these things. I conclude with the famous statement of Richard Feynman, pleasure in finding things out. That is how all these things have come out, and we see we are reaping the benefits, and we should remain to reap the benefits so that the pleasure which these great men have derived through their work is truly honored. Thank you very much for your patience. And what is the time now? Let us see. If there is time, I can do some more, but else if there are anything to discuss, we can discuss. Otherwise, I will.
You can show a few more slides, sir, if you want to show anything.
Oh, okay. That tomato crop thing, can you pull out? I will ask Ajat to pull out. Or I think go to that Infosys thing. Yeah, that Infosys thing itself you put so that another important issue I can raise. Yes. Just give me a minute. Because recently, I was invited to give a talk at Infosys on reimagining the world with AI. I thought that will be very relevant if I can get that. Want to call him and find out?
Yeah, just.
Or okay, then fine. Or you just yeah, I think we got it.
Okay.
Yeah. I'll share because this was done with Infosys, but I don't mind presenting. Go through this. So it's again related to AI, so please bear with us. Okay, it's full screen. Are you able to see the screen?
Yes, sir.
Yeah, I'll quickly presentation mode. Yeah.
No perfect, sir.
So reimagining the world with AI, that was the theme. My student Samay Patel said this, therefore I thought I will keep it. Before reimagining the world with AI, we must first ensure that we have a world to reimagine. So this is very, very important, because if we give all the autonomy to these machines enabled with AI, a time may come when we may have no place. So why AI? Because complex insights, predictive analysis is essential. One of the main problem with AI is a lot of energy consumption. This is a very serious thing. The energy consumed by these algorithms is estimated to be 7th place in the world. I mean, many countries don't consume so much power as these machine learning things are consuming. This is a very important slide. Earlier, the whole architecture was a pyramid architecture with human at the top, because we claim ourselves to be intelligent. All other creatures are subservient to us and we are the boss. But now we have understood with hard lessons that this is no longer true. We have to have a spherical structure where we are also an element, nothing more than that. And this is another thing, very instructive. This is during COVID. You see the left picture, COVID in the Gangetic plains, the dolphins had appeared. Why? Because human intervention was not there, that's all. Now humans have invaded, dolphins have disappeared deep into the sea. Right side picture, I think still it is green in our memory. What happened in Wayanad? We were mindless in occupying, ruthless in using the natural resources. We saw the collapse. Sustainability is very, very important. And this is a survival requirement, not a charitable choice. So, United Nations itself has said meeting the needs of the present without compromising the ability of the future generations to meet their own needs. So we need to look at food and water, clean environment, well-being and security. Well, we have done some work with mango crop detection and using our own data set. We can pick up how many mango groves are there through segmentation. Once you detect how many are there in each, how many mangoes are there, we can also detect. We can estimate this. So mango yield prediction is possible, and you can see the second row, first column. Even when the mango fruit is covered with the leaf, we can detect the complete mango. And we can also grade the mango. We can get the size of the mango also. We can get the number of mangoes. That is the beauty of these algorithms. Similar things we did for tomato. And we published it. We can fly the UAV, and this is the scenery from the UAV, and then we can pick up each and every tomato. When we published this was published in Deccan Herald. We got a lot of accolades from them, and we have done similarly for the pomegranate farm. I'm just showing you what are the possibilities with, see, we can pick up everything. We can identify the height of the canopy, diameter of the canopy, the weeds in the crop, and how many fruits are there. All these data you can get using the imagery. I will not. Then we have used it biomechanics. This is my marketing slide, because I've taught some of the cricketers. So you see, for example, this one. Today it is possible to pick up each and every joint mechanisms. When you jump, I'm doing here from Adho Mukha Svanasana, Utkatasana. What are the forces that come on the joint? Everything using AI we can estimate. You see, we are showing how the joint, knee joint can be tracked continuously just from one video. Then breast cancer, I think we did showed you. I'll quickly go to another. We are creating some sort of a gym platform.
As they sway and shuffle, your task is to
where
ensure they
exercises
remain
can be
perfectly
done,
aligned.
shown.
Let's choreograph this symphony of motion.
So we can make it mimic. The tutor will be there.
Lift your legs
You
up and
can do
away
the
from your body.
exercise.
Bring your right
Number of
knee to your
repetitions,
chest and
whether
tap.
you're doing it
As they
right or wrong. And the autism, this I showed you. I'll show you one more important societal, this is one very important thing. Cerebral palsy prediction in infants using AI. We have a project with Indian Council of Medical Research. We are doing with St. John's Medical College and MS Ramaya Medical College. You see, newborn kids, they do some of the movements. And through those movements, it is possible to do a risk prediction of their risk of developing cerebral palsy. But this needs a lot of understanding from the physician, and such neonatal physicians are hard to get. Not only here, even in other countries, and in remote places, it is impossible. So we thought that if you can record their movements through a mobile phone, that's why you can see a mobile phone there. Later we can train a imagery using what you call a general movement analytics using the ML and DL architecture, so that risk prediction should be possible. So that's what we are doing. We have a big team working on this, thanks to some of the doctors at both MS Ramaya and St. John's. So we are creating a database of the kids' movement, and you can see that this is all from the pose estimation algorithms. This is what you see here. You can predict. So host of all this modeling is possible, by which if the at home also, hopefully in the future, they can fix a mobile, get that all that fidgety movements. Through that, it is possible, because they say that many a times it cannot be detected as late as 11, 12 years, and the early prediction can help to save a lot of children. Well, that is it. I thought I will share with you. Other violence activity, etc. I have already shown. With this, I think I will conclude. I thank Karnataka Science and Technology Academy and all the officials for inviting me to give this talk. And I also thank all the participants. I only hope I have not disappointed, because I also included many of my work. Thank you very much. Namaste. Any questions? Yes, we can take.
Thank you very much for a very scholarly and insightful talk on the works of Nobel 2024 in physics. You took us from the basics and how artificial intelligence and neural network have been used in the physics research. I'm sure many of the attendees, both on Cisco WebEx and YouTube, will certainly appreciate your talk, and they have a lot of take-home message from your talk. And when we thought of this particular talk on Nobel laureate, I immediately told none other than Dr. Omkar sir can deliver this talk, because you have a good
Thank you, Dr.
background,
Ramesh.
neural network and artificial intelligence, and you have brought out the research So of both the Nobel laureates so well, sir. On behalf of KSTA and all the participants, both on Cisco WebEx and YouTube platform, we are greatly thankful to you. In spite of your busy schedule, you have kindly accepted my invitation to deliver this talk. Once again, thank you, sir. And if there are any questions, Umesh, please ask.
There are no questions from the audience, and I have requested them to post. So as of now, there are no questions.
Oh, yeah, there is one question now.
No, yes, sir. How are Boltzmann's network different from others?
I didn't get the question.
How are Boltzmann networks different from others?
Oh, there are plenty of architectures. You see, Boltzmann's was one of the initial things, but now more sophisticated architectures have come up. So it's what we should look at is how they have inspired the connectedness to do some storage and recall.
Thank you,
Umesh?
sir.
Yeah,
Thank you, sir.
any other question?
No, sir. I think
Oh, no, our Madhavaya sir has joined. Thanks for insightful session. Sir, your classmate Madhavaya sir has joined.
Thank you, Madhavaya. Thank you.
We have with us Dr. P. Nagaraj sir, Dr. P. M. Patil, Professor Madhavaya sir, Dr. Sindhu. Thank you very much. Now this session is open for your comments. First, Nagaraj sir, P. Nagaraj sir, Professor of Physics. Sir, over to you, Nagaraj sir. ಕೇಳಿಸ್ತಾ ಇಲ್ಲ.
Yes, sir. Now, sir?
ಈಗ ಕೇಳಿಸ್ತಾ ಇದೆ sir.
Yeah, sir. Thank you very much, sir, because your talk was very nice. And of course, nowadays, everybody is thinking only on AI. And that too, I don't know whether the physics will exist or not. And in case if you want to teach our physics, we have to go for AI. We don't know how we can
Very true, very
include
true.
that in our physics curriculum. Thank you very much, sir, for enlightening us about the AI. Thank you, sir.
Thank you, sir.
Professor P. M. Patil sir is there with us. Recently got Satish Dhawan Award from KCST. Sir, Patil sir.
Congratulations, sir.
P. M. Patil sir. Professor Madhavaya sir.
Sir, hello. Hi, Omkar.
Madhavaya.
Now, this AI world is revolutionizing our own real world. Now, what is the solution for the next generation kids? I am always concerned about that.
See, our concern is basically, for example, I keep visiting a lot of engineering colleges. Everywhere the hardcore engineering is quite fading.
Yeah.
AI, there are 10, 12 branches and thousands of students for computer science. So this is really it's a big concern.
Yeah, even at IISc, 50% seats are vacant, I heard.
Correct. Many colleges are verge of closing. So this is a real concern that especially with the Prime Minister's motto of skill in India, make in India, I think we should look at hardcore engineering, some way of attracting these youngsters and telling them that this is not the only way. There are things that we should, I think these kind of things should start from, I think KSTA is a good thing to conduct some sort of campaigns so that the skill set is nurtured.
Omkar, I have another small question. what should be the curriculum for the next generation kids in this era of AI? Because AI is gobbling up everything.
Yes.
So whether we should teach them at the early stage or later in the degree at the degree level, or where we have to start off with the AI exposure, because anyway it is covering up everything.
Correct, correct. No, not only that, even at IISc, I think at the director level itself, there was a committee set up to look at how to teach in this era of ChatGPT. Because these days giving assignment and all those things has no
value for it. Meaning also.
no meaning. And there are softwares which can give it in your handwriting.
Yeah.
Forget all Times Roman calligraphy and all that. You can train a network in your handwriting and it can give you in the handwriting of that person.
Oh.
So I think there need to be some sort of a way of looking at these things. People should get together how to really, bring
This is going to be the negative effect, because the more and more we use AI, our own brain will become dumb, I think. So
no, not only that, what happens is now we are getting, because with our students, Ajat and Samay, I was also discussing. Now we are taking a lot of information from AI, ChatGPT, and we are giving it the same thing to ChatGPT. Because again, we write some documents, we will upload somewhere, it will access that. So ChatGPT is also again learning from ChatGPT only.
yeah.
So it is becoming a negative feedback to the system. So this is a real concern. I think there is a need to look at and impress upon that wetting the hands with hardcore engineering must be given due importance. We really looked at.
Thank you, Omkar. I will see you sometime later.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
May I ask a question, please? May I ask a question?
Please.
Yes, sir, please introduce and please ask.
Yeah, myself, Basuraj Kagli, Physics Department, Bangalore University.
Welcome, Kagli sir.
I just want to know, can you explain briefly, you mentioned this back propagating algorithm. Can you explain briefly? It must be a difficult concept. In simple words, how does it work?
Simple differential equation, that's all.
What is back propagating?
Because now you get an error. In neural network, what happens? There is an input layer, hidden layer, and output layer. So when you give the input, some output will come. Now initially what they do, we randomly assign weights to each of these connections. So some random output you get.
Yes.
There is going to be a desired output. You find the difference. That is called error. Difference between the actual output that has come vis-a-vis the desired output. That error is there. Now that error is backward propagated in order to adjust the weights. So you keep on doing that till you get the desired output. So the weights,
like a feedback network.
Correct. The weights will now settle down to give you the desired output. So that is called the back propagation of the error.
Thank you, sir. Thank you, Kagli sir, for joining.
Okay. Okay, sir. Thank you.
It's a simple mathematical tweaking that is done there.
Yeah, but the number of connections is almost infinite, very large number you require. How is it actually done?
That's why they take high computational time. And also that becomes like a black box that will not tell you anything about the physics of the phenomena. But now we have what is called as physics informed neural networks called PINs, where you can inbuild some physics knowledge into the network. But still, yes, they have their limitations, and making them full autonomy has its own problem.
Yes, yes, I understand. Thank you. Thank you.
Thank you, sir.
Thank
Now, Dr. Sindhu, are there any questions from you or comment? Dr. Sindhu, Dr. P.M. Patil? Thank you, sir. Thank you for a very nice talk and later good discussion
Yeah.
because of the presence of Dr. Nagaraj sir, Dr. Madhavaya sir, and Kagli sir. For all of you, thank you. And the last talk in this series will be on Monday by my friend Dr. Chakravarti. He will be speaking on Nobel laureates work on biology, physiology or medicine. So all of you join by 11:30. Till then, thank you. And once again, thank you very much, sir. Omkar, sir.
Will you please share the YouTube link?
Yes, sir. Yes, sir.
Yes, sir, I will share, sir. I will share, sir. Thank you.
Oh, thank you. Thank you. Thank you.
Thank you, sir. Thank you.
Thank you, Nagaraj, sir.
Thank you, sir. Thank you.
Namaste.